Hello and welcome to part 1 of my Othello/Reversi game tutorial. Together we will program this game in C# using the Unity game engine. For now, we will implement the game to be played by 2 human players. In the future, I want to bring you videos about AI, and then we can create some computer controlled players for this game as well. If you are interested in that, then subscribe and let me know in the comments. There is a bit of confusion around the name of this game. The real name is Othello, but it has been called Reversi so many times that most people think they are the same. Reversi is actually a slightly different game, which is not really played anymore. Alright, we must know the rules of the game before we can program it. Othello is a 2-player board game. One player is black and the other one is white. It is played with discs that are black on one side and white on the other. The game board, which is typically green, has 8 rows and 8 columns. The game starts with 4 discs placed in the center like this. 2 are white side up and 2 are black side up. Black moves first and the players take alternate turns after that. A move consists of placing a disc on the board with your color facing up. But only some positions are legal. The disc must be placed in a position that outflanks one or more of your opponent's discs. This means that you sandwich them between 2 of your own discs. All outflanked discs are then flipped so the other color faces up. You can outflank discs horizontally, vertically, and also diagonally. It is possible to outflank multiple discs at once, even in multiple directions. Sometimes the current player cannot make any move. In this case, their turn will be skipped. If neither player can move, then the game is over. This usually happens because the board is full, but not always. The winner of the game is the player with most discs of their color at the end. If there is an equal number of black and white discs, then the game is tied. Let's open Unity and get started. Create a new project. Choose the 3D template and give it a name. First of all, we will import some assets I have created for the game. You can download them from the link in the description. There are 2 3D models, one for the game board and one for the discs. We also have a texture for the game board and a wood texture, which is for the background. Finally, we have these disc sprites, which are for the UI. Let's just drag and drop these into the assets folder for the project. Before we do anything with these assets, we will implement the rules of the game. The goal in this video is to write the actual Othello game logic. First, I will add a scripts folder, and inside that, let's create a C# script called player. It will be a simple enum, so we can get rid of all of this. And it shouldn't inherit from mono behavior. And we don't need these imports either. What we do need is 3 enum values: none, black, and white. This enum will be used to store which player's turn it is. We will also use it to store the contents of each position on the game board. For convenience, let's add an extension method which returns a player's opponent. To do that, we need a static class. The opponent method should take a player parameter and also return a player. If the player is black, it returns white, and vice versa. If the player is neither black nor white, we return player.none. Next, we need a simple class to represent a position on the board. Note that this class does not inherit from mono behavior. You could also use a struct for this. It will simply store a row and a column. And let's give it a constructor. It will just initialize the properties. As you will see in a minute, we will use this class as the key in a dictionary. For that to work, we will override both equals and get hashcode. We start with equals. It should return true if the given object is a position, and it stores the same row and column as this position. In any other case, it should return false. Get hashcode looks like this. Here, we will simply return 8 times row plus column. This will give each position on the 8x8 board a unique hashcode. The final little helper class we need is called MoveInfo. As the name suggests, it will store some information about a move. We will store which player made the move, the position where they placed a disc, and a list containing the positions of the discs that were outflanked. Great. Now we have all the little pieces we need to implement the rules of Othello. We will do that in a class called GameState. This class is also just a regular C# class. First, let's create constants for the number of rows and columns. Next, we need to store some data to represent the current state of the game. We need a 2D player array called board. It will store what each position contains. Player.black means a black disk, player.white a white disk, and player.none nothing. To keep track of the number of black and white disks, we will add a dictionary. The key is a player, and the value is the number of disks with that player's color facing up. We also need to know which player's turn it is. Whether the game is over or not. And who the winner is. We will set this property when the game is over. Finally, we will store which moves the current player can make in the current state. As you can see, we will use a dictionary for that. Each move will be stored as a key value pair, where the key is the position of the move and the value is a list containing the positions of all outflanked disks. This will make it easy to check if a move is legal, and if so, which disks should be flipped. Let's write a constructor for this class. First, we will initialize the board array. At this point, every entry will contain player.none because it's the first enum value. But when the game starts, the board should look like this. I will use the convention that the origin, row 0 and column 0, is the top left position. So we have to set board at 3,3 to player.white, board 3,4 to player.black, board 4,3 to player.black, and board 4,4 to player.white. Next, we will initialize the disk counts. Both players have 2 disks at this point. Black starts the game, so we set current player to player.black. The default value for game over is false, and for winner it's player.none, so we don't have to set those. We do have to initialize legal moves, but first we must write some code to figure out which moves are actually legal in the current state. Finding legal moves is probably the most difficult part of writing an Othello game. Before we start writing the code, let me explain how it will work. The idea is to loop through every position on the board. For each of them, we will check if the current player can place a disk there. They can if the position is empty and at least one of the opponent's disks will be outflanked. It's easy to check if a position is empty. We can just look in the board array. Figuring out which disks will be outflanked requires more effort. We will reduce it to a simpler problem. Which disks will be outflanked in a given direction when placing a disk at an empty position? In this example, black is the current player. Here is the idea. From this position, we repeatedly move in the given direction. If we find one or more consecutive opponent disks capped off by one of the current players, then all the opponent disks we have seen will be outflanked. Concretely, it will work like this. From the empty position, we move once in the given direction. If we see an opponent disk, we save its position and keep moving. If we see the current player's disk, then the disks at every saved position will be outflanked. If we ever encounter an empty position, or we have moved outside the board, then no disks will be outflanked, so we can forget about the saved positions. Finding all outflanked positions can be achieved simply by checking all 8 directions. Let's open up the editor again and implement this little algorithm. First of all, we need a method called isInsideBoard. It takes a row and a column as parameters and returns whether or not that position is inside the board. Now we can write a method to find outflanked disks in a given direction. Here is its signature. Pose is the position where we want to check if a disk can be placed. The color of that disk is given by the player parameter. And the direction is encoded as two integers, r delta and c delta, which are simply row and column offsets. So for example, r delta equals 0 and c delta equals 1 would be the right or east direction. The method will return a list containing the positions of all outflanked disks in the given direction only. First, we create an empty list. We must also keep track of the current position. We start by looking at the position one step from pose in the given direction. So the row is r equals pose.row plus r delta. And the column is c equals pose.column plus c delta. Because we need to take multiple steps, let's add a loop. It runs while we are still inside the board and we haven't encountered an empty position. Inside the loop, we know we are looking at a position that contains a disk. If it belongs to the opponent, then we save its position. And then we move one step in the given direction. Otherwise, if the disk belongs to the current player, then we know that the positions we have saved in the list will indeed be outflanked. This if statement here is not really needed. You can remove it if you want, or just comment it out. If we ever exit this while loop, it means we have either moved outside the board or encountered an empty position. In this case, there are no outflanked positions, so let's return an empty list. Great. Now we can find all outflanked disks by checking every direction. This method is similar to the other one, except that it looks in all directions. First, we create a list for the outflanked positions. And then we will generate all directions with two loops. This will give us all directions, but also one where both r delta and c delta are 0. We don't want that, so let's ignore it like this. For every other direction, we will call outflanked in direction and add the result to the list. After these loops, our list contains all outflanked positions, so we just have to return it. Perfect. Let's create a method called isMoveLegal. It returns whether or not the given player can place a disk at position pose. If they can, the out parameter will contain the positions of all outflanked disks. If pose is not empty, then the move is certainly not legal. In this case, we set Outflanked equal to null and return false. If pose is empty, we get the outflanked positions. And return true if and only if there is at least one. Now we can finally write the method we wanted in the first place. It's called find legal moves. It takes a player as parameter and returns that player's legal moves as a dictionary. Recall that the key is the position of the new disk and the value is a list of outflanked positions. We start with an empty dictionary. Then we loop through every position on the board. Inside the loop, we save the row and column as a position and check if the given player can place a disk there. If they can, we save both the disk position and the outflanked positions in the dictionary. And outside the loop, we return the dictionary. In the constructor, we can now initialize the legal moves. The next thing we need is a public makeMove method. It takes a position and returns whether or not the current player was able to place a disk there. If the move was successful, the MoveInfo out parameter will contain additional information. We will need a few helper methods to complete the implementation, but let's get the bigger picture first. First of all, if the move is not legal, we just set MoveInfo to null and return false. Note that we didn't actually have to call our isLegalMove method to check if the move is legal. We keep all legal moves stored in a dictionary, so we can simply check if it contains pose as a key. Alright, if the move is legal, we store the current player and get the outflanked positions from the dictionary. We also have to update the state. A new disk should be added to the board. And then we need to do a few more things that we will implement in a second. We have to flip the disks at the outflanked positions, update the disk counts, and pass the turn to the other player, or potentially find a winner if this move ended the game. Once that's done, we can set the MoveInfo and return true. Okay, let's add a flip disks method. It takes one parameter, a list of outflanked positions. For each of them, we change the corresponding entry in the board array like this. A black disk will be changed to a white one, and vice versa. Back in MakeMove, we will call the method with the outflanked positions. The next method will update the number of black and white disks. It takes two parameters, the player who moved and the number of outflanked disks. The outflanked disks will now be the moving player's color. So we add outflanked count +1 for the disk that was placed during the turn. And for the other player, we must subtract outflanked count. Let's go back to MakeMove and call this method with outflanked.count. Now we just need past turn. To implement that, we will first add two helper methods. The first one is called changePlayer. It simply updates the current player using the opponent method. And then it finds the legal moves for the new player. The other method we need figures out who won when the game is over. If black has more disks than white, then black wins. If white has more disks than black, then white wins. And if they have the same number of disks, we return player.none to indicate a tie. Great. Let's write the past turn method. First, we try to change the current player. If the new player can make a move, then we are done and we can simply return. Otherwise, their turn should be skipped, so we change back to the original player. If this player cannot move either, then the game is over. In this case, we set current player to player.none, game over to true, and then we find the winner. Now we can finish MakeMove by calling past turn here. That's it for MakeMove. We will add one final convenience method and then we are completely finished with the game logic. The method is called occupied positions and it looks like this. It just loops through every position and returns those that contain a disk. That's it for now. In the next video, we will set up the scene and make the game playable. That will be pretty easy to do now that we have all the rules implemented. See you next time.